Now, way back, I believe it was chapter 1, we talked about descriptive studies. And we talked about how if you do a descriptive study where you're just measuring variables that are already in existence, all right, you're not manipulating a variable in any way, you're not creating categories of a variable, you are not going in and manipulating somebody's environment or their thoughts or anything. You're just going in and you're recording what's already there. The statistic that would be appropriate would likely be correlation. All right. Now, we didn't talk about correlation way back in chapter 1, but the reason why I want to revisit this idea here is because we established one of the weaknesses with descriptive research. Because you're not manipulating anything, it means you're not controlling anything. It means that you're not trying to isolate the effect of X so you can see what effect that has on Y. All right. In a descriptive research scenario, without any kind of control over what's going on, the best we can say is that the variables are related to each other, but we can't say that one caused the other. That would require a true experiment. All right, so we would have to take a variable like X, create specific categories, randomly assign people to those different categories or levels. Remember that? Levels of X. Make sure that no extraneous variables are interfering with our study. And then look at the effect of X on Y. And then we would do that by saying, okay, if there's 3 different groups of X, right, 3 different categories, we see, well, what effect did category A have on Y? What effect did category B have on Y? And what effect did category C have on Y? Right? And if there's no other variables that can be interfering, then we say we've isolated the effect of X on Y, and we can make causal statements. But if all you're doing is going in and recording X, recording Y, you're not controlling the environment, you're not doing any kind of manipulations, just because you find a correlation between X and Y does not mean that that relationship is causal. And I believe I talked about the shark example, right? Shark, as ice cream consumption increases, so do the number of shark attacks. All right. But that doesn't mean that eating ice cream causes sharks to attack, right? So we have to be very, very careful. We lose sight of the fact, especially when we get a very high correlation, right? So if we get like 0.7, 0.8, 0.9, we want to believe that, oh, X must therefore cause Y. But that is not true. In fact, the correlation between X and Y can be perfect. It can be +1 or -1. It's still not the case that X necessarily caused Y. All right? It could be. That's a possibility. It could be that X caused Y, but it could also be that Y caused X. And there's a third possibility, and that is that there were one or more other variables that are responsible for the relationship and making it appear as though X caused Y. All right. So is there a correlation between ice cream consumption and shark attacks? Absolutely. There is a mathematical relationship between ice cream consumption and shark attacks. We know this. We've done the math. But does that mean that ice cream consumption caused sharks to attack? Probably not. What is most likely what's happening, right, is that, as temperature, outside air temperature increases, that sends more and more people to the beach, more and more people in the ocean. It's also when you want to drink, not drink, well, I suppose you could drink ice cream, but it's when you want to eat more ice cream is when it's really hot outside. And so the sad fact is that when it's hot outside, you're eating more ice cream, you're going to the beach, you're going into the water, and the more people in the water, the more likely somebody is to be attacked by a shark. So it has to do more with the number of bodies in the water than anything else. Okay? So I think it's pretty safe to say that eating ice cream does not cause sharks to attack. So, takeaway here. Okay, we have Judge Judy waving her finger at you. What does she want you to know? She wants to make sure that you understand, unless you systematically manipulate one variable, in other words, the independent variable, right? Systematically manipulate it. So create different levels of the independent variable, different groups, and then measure its effect on another variable, the dependent variable, while keeping all the other extraneous variables constant so they cannot interfere. Unless you do all of this, you cannot know what causes what. Now, Judge Judy, you forgot to say something here. Somewhere in here, Judge Judy should have said you randomly assign people to the different levels of the independent variable. That would make this even more complete, okay? So if you want to say anything about X causing Y, you'd better manipulate X, that's the independent variable, create different levels, different categories of X, randomly assign people to the different levels, then look and see what effect does each level have on the dependent variable, making sure that all other variables are kept out of the way. They're kept constant, you eliminate them, you do whatever you need to do so they cannot interfere. Then, if you see differences between the different levels of X, you can more safely, it's not going to be perfect, but you can more safely conclude X must have been the causal variable that resulted in changes in Y. Y changed because different people were exposed to different categories or levels of X. And that's what Judge Judy wants you to know. And me.